Welcome back, everyone. We are starting Unit 4, which is all about quadrilaterals and other polygons. We are going to be learning first about quadrilaterals in Unit 4A. Then we will move on to Unit 4B, which is all about areas and perimeters of different polygons. So first, on this first page, you'll see an anticipation guide. Depending on when you're watching this video, either we've already done this in class or you will be doing this in class. So go ahead and skip this for now and go to the next page where it says Goal 1 at the top. First, we need to learn some vocabulary words before we start this unit. Maybe you already know these, but I'll tell you them anyway. First is a diagonal. This is a segment that connects any two non-consecutive vertices. Non-consecutive means they're not in a row. Next is a regular shape. We've definitely talked about this before, but just as a reminder, a regular shape is a shape that has all interior angles congruent and all sides congruent. An example of a regular quadrilateral or a four-sided shape would be a square. It has all interior angles congruent and all sides congruent. Now, just as a refresher, here are the names of our different polygons. We have a three-sided triangle. You obviously know that. We've worked with those all year. We went over these earlier on in the year, but just as a refresher, we have a quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, dodecagon, and anything beyond that will just be the number of sides gone. So 13 gone or 40 gone, however many sides it is. Now, what we want to do is try to figure out if there's anything that we can do to try to find the sum of the angle measures of a polygon. What I want you to do is draw this little table here for yourself and see if you can list out the number of sides in the polygon, the number of triangles that we can create out of this polygon. And now let's see if we can figure out the sum of the angles in the polygon. So with a triangle, hopefully you have the number of sides is 3, quadrilateral 4, pentagon 5, hexagon has 6 sides. The number of triangles in a triangle obviously just has 1. A quadrilateral we can split up into 2 separate triangles. A pentagon, you should have seen there are 3 triangles. A hexagon can be split up into 4 triangles. Do you notice any pattern between the number of sides and the number of triangles that it can split up to? In a triangle, we know that the sum of the angle measures inside the triangle, or the interior angle measures, is 180 degrees. Therefore, if we look at a quadrilateral, since it can be broken up into 2 triangles, I know each of these triangles has a sum of the angle measures of 180 degrees. So that means the quadrilateral has 2 times 180 degrees, or 360 degrees. A pentagon would have 3 triangles in it, so 3 times 180 degrees, which gives us 540 degrees. Similarly, for a hexagon, since it has 4 triangles, we multiply 4 by 180 degrees to get 720 degrees for the total of all the angles in the hexagon. Hopefully you're seeing a pattern that if we can tell how many triangles it can be broken up into, we can tell the sum of the interior angle measures. That will lead us to this formula. The sum of the interior angle measures of an n-sided convex polygon is n minus 2 times 180. You subtract the number of sides, you take that minus 2, because that'll give you the number of triangles. We know each triangle has 180 degrees interior, so that'll give us the total sum. In a regular polygon, you can find the measure of each angle by taking the sum and dividing it by the number of sides, because the number of sides is the same as the number of angles. So both of these formulas are very important. Make sure you have these memorized. It's easy to memorize if you understand them. Alright, let's try this example together. Find the sum of the measures of the interior angles of a convex heptagon. So a heptagon is a shape with 7 sides, so that means n equals 7. We're finding the sum, so we want the equation that says n minus 2 times 180 degrees. I know that n in this case is 7. So that gives me 5 times 180 degrees, which I know is 900 degrees. Now let's try problem B. It says find the measure of each interior angle of quadrilateral ABCD. Obviously I already know angle B and angle C each have a measure of 90. But I need to figure out the value of x in order to find the measure of angle A and D. You may already remember the sum of the quadrilateral interior angles. However, if you forgot, we could always use our formula. The sum would be 4 minus 2 times 180 degrees, which gives us 360 degrees. So I know that all these angle measures, x, 3x, 90, and 90, altogether, each of these interior angles adds up to 360 degrees. So now I can solve this formula, or this equation. I'll combine like terms on the left side first. Next, subtract 180 on both sides. And finally, divide both sides by 4 to get x equals 45. Now I can go through and find the measure of each angle. The measure of angle A is 3 times 45. So the measure of angle A is 135 degrees. The measure of angle B, I already know that's 90. The measure of angle C is also a right angle, so it also has a measure of 90. And finally, the measure of angle D is just 45. Pause the video and try the practice problem below. Alright, here are the correct answers for that practice problem. Now let's do another one. This says the poles for a tent form the vertices of a regular hexagon. When the poles are properly positioned, what is the measure of the angle formed at a corner of the tent? So a hexagon, it has 6 sides, so it's asking for the measure of the angle formed at the corner. So that's looking for one individual interior angle. So I know that I will use the formula 6 minus 2 times 180 degrees divided by 6. That'll give me the measure of each interior angle. I have to subtract 6 minus 2 first in the parentheses. Then this gives me 120 degrees. So each corner of the tent has a measure of 180 degrees. Pause the video and try the practice problem below. Here's the correct answer. If you rounded, that's fine. It didn't give instructions on rounding. Next, it says we are going to find the number of sides. The measure of an interior angle of a regular polygon is 135 degrees. Find the number of sides in the polygon. So this is telling us the measure of an interior angle. What that means is one single interior angle. Each interior angle we can find by taking n minus 2 times 180 degrees divided by the number of sides or angles n. I know each angle measures 135. And I'm trying to solve for the number of sides, which is n. So I'm trying to find what n equals. So I have an equation. It only has one variable. You should be able to solve it for n. First, multiply both sides by n to get n out of the denominator. Next, distribute 180. Next, we can subtract 180n on both sides. Finally, divide both sides by negative 45 to get n equals 8. So there are 8 sides in this polygon, meaning that it is an octagon. There's a similar problem for you to try on your own. Here's the correct answer. This one is a decagon. Let's talk about the measures of the exterior angles of a polygon. I've shown you the exterior angles for a triangle, a quadrilateral, and a pentagon. Go ahead and see if you can find any pattern for the number of sides and the sum of the exterior angles. So I want you to add up all the exterior angles, see if there's any pattern based on the number of sides. Hopefully you noticed that no matter how many sides there are, the sum of the exterior angles is always 360 degrees. That's really convenient. We don't need any formulas or anything. So we can find the value of x in this diagram because they're all on exterior angles. So I know that all of these exterior angles must have a sum of 360. So this gives me an equation to solve. Combine all your like terms. 2x plus 5x plus 2x plus 6x plus 3x all together makes 18x. Negative 5, and positive 10 makes 0. Divide both sides by 18 and you'll get x equals 20. Now this one is asking us for the measure of each exterior angle of a regular nonagon. If you have a regular shape, each exterior angle will be congruent. Therefore, each exterior angle would be 360 degrees divided by the number of sides n. Make sure you know this formula. In this case, a nonagon has 9 sides, so n equals 9. So each angle would be equal to 360 degrees divided by 9, or 40 degrees. So each exterior angle is 40 degrees. It's really important that you pay attention whether they're asking you for each angle or the sum of the angles, and also whether they're asking you for interior or exterior angles. All right, try this one below. Here are the correct answers. And finally for today, I want you to think about this. Marcus says that the sum of the exterior angles of a decagon is greater than that of a heptagon because a decagon has more sides. Liam says that the sum of the exterior angles for both polygons is the same. Is either of them correct? Explain your reasoning in 1 to 2 complete sentences. Tomorrow we will be focusing more on quadrilaterals specifically, which is what this chapter focuses on a lot. So we will be back then.